Let us solve a problem using Kirchoff's rules. We are given this circuit consisting of 4 batteries and 3 resistors. The batteries are non-ideal. They all have an internal resistance. We have the resistor R1, R2, R3, and we are asked to find the current through each branch. We are going to do that by using Kirchoff's rules. The first thing we do, if you recall, we choose a direction for each current, and we are choosing these directions randomly. There is absolutely no reason why I chose I1 pointing in this direction, I2 and I3 in these directions. This is something that we choose totally randomly. And we apply Kirchoff's first equation, let's say in junction B. Remember, Kirchoff's first equation says that the sum of the currents going in is equal to the sum of the currents coming out. So if we look at junction B, current I1 goes in, and currents I2 and I3 are coming out. This is our first equation. Needless to say, we cannot solve it. We need much more than this. So we are switching to Kirchoff's second equation that we will apply it twice. We will apply it to the left loop and to the right loop. So let's label this loop L, and let's label this loop R, left and right. The way we apply Kirchoff's second equation, if you recall, we choose a direction around the loop. So let's choose this direction to be clockwise. Kirchoff's second equation says that the sum of all the EMFs around a loop is equal to the sum of all the IRs around that loop. So for the left loop, let's see what we have. We have 3 batteries. We have batteries E1, E4 and E2. And I'm going to write those 2 batteries without the signs, because we don't know what the signs are. And on the right hand side I have all the IRs present in the loop. And if I'm looking here, what IRs do I have? I have I1 R4, I have I1 R1, I have I2 R2, and I have I2 R2. Let's take a moment to look at all of them. I have the batteries that I have are E1, E2, and E1, E4, and E2. I just listed them here. And the IRs are I1 R1, I1 R1, I1 R4, I1 R1, and I2 R2. And I'm missing an R here, sorry, so this is why it's good to check. So I1 R4, I1 R1, I1 R1, I2 R2, and I2 R2. We have current I1 going to R4, to R1, and to R1, and these are these 3 terms. And then I have I2 going to R2 and to R2, the little r and big R. So now the question is to find the signs. Well, I'm going around the loop as indicated there. So if I look at this, I'm crossing the battery E4 from plus to minus, which means this would be negative. I'm crossing E1 from minus to plus, which makes this one positive. And I'm crossing E2 also from minus to plus. This will also be positive. So please pause for a moment and try to appreciate each of these signs. I'm crossing the battery from plus to minus, which is negative. I'm crossing this battery from minus to plus, makes it positive, and I'm crossing this battery again from minus to plus, I'm making this positive again. And when it comes to the IR terms, remember, if the direction that I chose goes with the direction of the current, that is positive. If it goes in the opposite direction, it's negative. Here it looks like they are all positive. The direction that I chose coincides with I2 here, so both these terms are going to be positive. While here it coincides with I1. So we have this second equation, and we'll come back later, we plug in the numbers. Let's just take care of the third equation. We do this in the right loop. Let's continue going clockwise. So I'm going clockwise, I'm listing all the batteries around this loop, and I have two batteries, E2 and E3. And on the right hand side I have a bunch of IRs. If I'm looking at them, I have I3 uppercase R3, I have I3 little r3, and I have the I2 R2 and I2 little r2. So for now I just listed them. Again, I have to account for all the batteries, and I think I did, right? E2 and E3. And I have to account for all the IR terms. And indeed, I have I3 R3, I have I3 little r3, I have I2 big R2, and I have I2 little r2. And now let's look at the signs. Battery E3 is crossed from plus to minus, which makes this negative. While battery, the second battery is also crossed from plus to minus, which will make this negative again. So please make sure you understand what we did here. I'm going around the loop clockwise, and as I do that, I'm crossing this battery from plus to minus. That means I have a negative sign here. And as I go around the loop, I'm also crossing this one from plus to minus, and therefore this is also negative. Don't look at what we did earlier, because it's all about what direction I go around the loop, and the directions might not agree. So don't look at this based on what we did earlier. And when it comes to these terms, these are positive, but these are negative. Notice how when I go clockwise, I'm going in the direction of I3, so this is why these two terms are positive. But when I go here, me going clockwise, I go heads-on with respect to current I2. So because of that, this is going to be negative. And although it looks complicated, I know a lot of numbers, so I'm rewriting this as a system of equations. I1 equal I2 plus I3 is the first equation, and then I have this, and I know all the numbers. So 54 plus 10 minus 15. I'm looking at the values that were given to us here. All right, 55 plus 10 minus 15 is equal to I1. I1 times the sum of these resistances. So R4 is going to be 0.2. R1 is 9.5. And little r1 is 0.3, and then I'm here plus I2, it will be R2 plus R2. I'm looking at them here, I see them right away. It is 0.4 plus 19.6. And for this system of equations, minus I2 minus I3, so it will be minus 10 minus 30, minus 10 minus 30 is equal to I3, R3 plus R3, it is 0.9 plus 0.1, and here we have minus I2, R2 plus R2, 19.6 plus 0.4. So if you want to look at these values one more time, if you missed them before, and these are the numbers that we plugged in here. So this is a system of equations that can be solved. This is equal to 50. Here we see is 10, so it is 10 I1 plus 20 I2, while here we have negative 40 is equal to 5 I3 minus 20 I2. In principle, we should be able to solve this system of equation, right? It is basic algebra, so I1 is equal to I2 plus I3, stays put. Here we can simplify by 10, so we are left with 5 is equal to I1 plus 2I2. And here we simplify by 5, so we are left with negative 8 is equal to I3 minus 4I2. This is a system of equation that we should all be able to solve, but we can also use some online calculators for a situation like this to save a little bit of time. So I'm using an online calculator. I just googled system of equations solver, and this will give me the answer in just a second. I typed in the online calculator x is equal to y plus z in the system that I found. Then I typed the second equation as x plus 2y, and I typed in the third equation as negative 8 is equal to z minus 4y. This is, and the answer somehow doesn't want to calculate it, so I guess we'll have to do it together. I have to do it by hand, but which is really not that bad, but I was hoping to save a little bit of time. So we have this system of equations that we can solve. So my suggestion is to plug I1 from the first one into the second. So the second equation becomes 5 is equal to I2 plus I3 plus 2I2. I replace I1 by I2 plus I3, and the third equation stays put, I3 minus 4I2. Not sure why my online calculator didn't work. So 5 here is equal to 3I2 plus I3, while here minus 8 is equal to A3 minus 4I2. This has not changed yet. And now I am ready to subtract these two equations if you want, or if you want to do substitution. So I3 from here is 5 minus 3I2. So that means the third equation becomes minus 8 is equal to 5 minus 3I2 minus 4I2. So 7I2 is equal to 13, or I2 is equal to 13 over 7. A 1.5 85 amps. And now we go back to the previous equation. I3 is 5 minus 3 times 1.85 amps, and this will give me a value of I3 of negative 0.57 amps. And of course, if I go back to my first equation, I1 is equal to 1.85 minus 0.57, so I1 is 1.22 amps. You are probably thinking already, what happens with this negative value? What does it mean? Well, it means that the direction of the current that I chose originally was wrong. So I'm going back to my original choices. So I1 I chose to be in this direction, and because I found a positive value, that means it's correct. I2 I chose to go down, but again it's correct, it's positive. But I3 I chose it to go down, and I found here a value that is negative, which means I chose wrong. So if I redraw my original circuit real quick, so we had these two batteries, and the battery here, and the resistor here, and of course another resistor here, and this battery here. So this was my original circuit. So now I chose I1 to go up, and because I found I1 to be positive here, that means that this is correct, 1.28 amps going in this direction. I2 I chose it initially to go down, so because of that and because it is positive, that is going to be correct. But I3 I chose it to go down, and now I got a negative value, which means I'm simply going to flip the direction of the current. So if you look at your original picture when we started and now when we ended, look how I3 used to point down at the beginning of this problem, but now it points up. And the reason for that is because I found a negative value here for the current. And there is another question that they're asking us in this problem. They're asking us to find the potential difference between points A and B. So this is a very good exercise for us. So they're asking us to find what is the potential difference between points A and B. So let's just draw only that part of the circuit. I am going to take out the resistance as we saw in an earlier video. So I'm drawing this part of the circuit again. So this is E2, which we know it is 10 volts. This is the internal resistance of that battery, little R2. It was 0.4 ohms, and this is the big R2, which is 19.6 ohms. And again, by now we know, as we saw before, we know that we have a current flowing in this direction with a current of 1.85 amps. So what do we do now? We label all these points. So points B and A have been already labeled for me, but I need to label all the other relevant points. So I'll have point C, and I will have a point D. So I'm going to write the potential difference between each pair of points according to the rules that we saw in an earlier video. So VB minus VC is going to be negative 10. Please appreciate what we are doing here. The battery here, the plus is here, so that means point C is at a higher potential, but I'm starting from the top, so I'm saying VB minus VC is equal to negative 10, because VC is greater than VB by 10. Then I'm saying VC minus VD is the current multiplied by the resistance, so it will be 185 times 0.4. Of course, these are all volts. 185 times 0.4 because the current goes from C to D, so potential of C will be greater than potential of D. Then I have finally VD minus VA will be 1.85 times 19.6, and again the current goes from D to A, and we add all of them up, so VC will cancel out, so I'm left with VB minus VA is equal to negative 10 plus 185 times 20, which gives me a value of 27. So VB minus VA in this case is 27 volts. Or because they asked for VA minus VB, VA minus VB is negative 27 volts. So please take a moment to see what we did here, right? We go, they're asking for the potential difference between the 2 points. So what we do, we write the potential difference between each pair of points according to the rules that we already know, and then we add them up. Remember, this is the approach that we took when we first saw how we derived Kirchoff's second equation in the first place. And we always write like this, and the middle terms will always cancel out, so we are left only with the first and the last point. And of course, in the process of adding all these things up, in this case it was minus 10 plus 20 times 1.85, that is about 37, so minus 10, 27. This is how we find the potential difference between 2 points. So please go back around these loops and make sure you are able to write these equations, and be careful not to omit any signs, because the whole answer will be affected, of course.